Okay, so I'll first do a short presentation to introduce this department. And first, a few highlights about the department. We are Department of Biostatistics at Johns Hopkins Bloomberg School of Public Health. And so why should you be here as a graduate student? Right? So we always want to give you some highlights. First, of course, is we are all working on fascinating problems, very important scientific and statistical problems. And people here are very happy. And then we are a very collegial department. People are supportive of each other. And our students eventually land on great jobs. And also during your 2 or 5 years of study, depending which program you are in, you are going to learn the foundational skills in terms of both statistics and science. And that can be applied to many different problems and scenarios. And also, you are going to work closely with your advisors and mentors in an apprenticeship model to learn new knowledge and also create new knowledge. And in our department, we have people working on many different things, ranging from, say, basic biology, genomics, to public health, policy, and then to more theoretical aspects like statistical methods and longitudinal high dimension methods. Right? And so students usually anyway, so this is a great place for you to launch your career and build your career and then prepare yourself for the next step. Okay? And then first, you may wonder, what is biostatistics? Right? In order to answer that question, we probably need to ask ourselves, what is statistics before we talk about biostatistics, right? So what is statistics? If you know probability, you probably know probability studies is data, how a model can be used to describe data. Here, model usually is a mathematical model, right? So you have some probability distributions. And then so you have a model, you want to use it to explain the data. And the statistics does things in a reverse way. It says you now have the data, but you don't know what the underlying truth, the model is. So you want to use the data to infer the underlying truth or the underlying model, right? So that's statistics. And the biostatistics basically means you are going to apply all these statistical and probabilistic principles to solve problems that somehow related to biology, public health, or medicine. Right. Here, actually, biology is defined very broadly, and you can see in our department we have people like me and Margaret who work on genomics, DNA. That's hardcore biology. But there are also people working on policies like crime, right? So you wonder why is that related to biostatistics? How is that related to biology, right? So that's what I mean by we define bio broadly. So that obviously is related to public health. Right. So that's why we call ourselves biostatistics, but we actually work on a broad range of problems that not specifically just narrowly defined as biology. Okay. Okay, so these are some examples of the problems we are working on in this department. For example, some people work on which genes is underlying the breast cancer, and then how can we treat different tumors. And some people work on public health problems like does folate provide pregnancy benefits via, say, epigenome, like DNA methylation, others. Some people work on what policies or programs can reduce violence. And some people work on, for example, which COVID patient progress to poor outcomes, et cetera. This is just a small sample of what we're doing in this department. And so while you are working on all those fascinating problems in the department, people in the department also get a sense of satisfaction and achievement by realizing that we are constantly learning new things, right? So throughout your whole life, actually, if you are working in academia, you are going to always learn new things every day. And you are working with great colleagues, including great faculty member and also your classmates, and then also your lab mates and others. And you get a satisfaction because you are advancing science. Obviously, you're creating new knowledge. And then a lot of this new knowledge actually will make an impact. You are going to change how people run clinical trials. You are hopefully going to provide some evidence to let people change the policy, which will then impact a lot of people. So you are, in many cases, making a difference, hopefully towards the better direction for the world. Okay, and so for students, when they graduate, they often go into 3 types of jobs, right? So academia, government, or industry. But regardless of where you go, usually you get a very decent salary. And so these are some examples of the jobs that our students take after their graduation in the past 10 years. And on the left-hand side, you can see these are the academia universities. It includes, for example, Johns Hopkins University, Duke, Harvard, Columbia, etc. And in the middle, you can see like the industry jobs. Our students go to places like Google, Facebook, and also in the pharmaceutical company like Genentech, and then Eli Lilly, etc., etc. And then we also have students who go to government like NIH, FDA, as well as other research institutions like Fred Hutch or Liber Institute. So this gives you a sense of like where our students go after graduation. And in terms of the size of the department, we are a medium-sized department. And currently we have 24 tenure track or tenured faculty members. And additionally, we have 20 research faculty. And then in terms of students, we have a PhD program consisting of about 50 students. That is about 10 students per year. And then we have a 2-year SCM program. In total, we have 35 students in that program now. And then we also have a few MHS students. These are students who like are PhD students from other department, but they are pursuing a concurrent degree in biostatistics in our department. And then we have 14 postdoc fellows, and then these are students who get their PhD degree from some other universities, and then come here, join our like research groups, and then doing kind of independent research with us. So that's kind of a overview of the who are in this working in this department. And then obviously we have also many jointly affiliated or jointly appointed faculty members, and then you can get all this information from our website. Okay. So this is like in terms of the structure of the university, and then the university has a lot of schools, and then we are in School of Public Health, the Bloomberg School of Public Health. And within this school, we have 10 different departments, and the biostat is kind of the core department, which offers the quantitative training and research. And then within our department, in addition to our tenure track or research faculty members, we also have a biostatistics consulting center, which supports the collaborative needs across the university. So often people have many important projects, but they need some statistical support. So they often go to this consulting center to get support. And then we also have a joint high-performance computing exchange, which basically provides the hardware, the computing hardware support for the department and then for the school as well. So if you need to do high performance computing, there's a cluster maintained by this group, okay? And then a little bit about the history of the department. We are always proud of the fact that we are the oldest department of biostatistics. We are founded in 1918, the first department of biostat in the whole world. And then we are constantly ranked among top 3. And then usually when you go to places like US News, you can see like top biostat programs, Harvard, Hopkins, U of Washington are the top 3. And then so we are very proud of that. of course. And why we are always ranked among top? I think one important reason is in our program, we do provide rigorous training that spans both biostat and data science. So in this department, if you are students, you are going to get training in both basics about statistics, basics about data science, and also skills and techniques in terms of how to work at the interface between statistics and health sciences. And all of this training is trying to help you to do impactful work that will benefit the whole society. And then, as I mentioned before, in this department, students and faculty work in an apprenticeship model, so you work closely with your advisors and mentors, and to develop your knowledge and also create new knowledge. And we are a community of scholars. We have many working groups working on different things. So perhaps this is next slide. You can see like we have people who work on Bayesian statistics, spatial modeling. We have people working on like causal inference. We have people working on aging. We have a genomics data science working group. We have a genetics working group. And then we have people who are working on wearable devices, like this is called smart, right? So they are smart people. They use, say, your iPhones to monitor your daily activity, things like that, and then trying to figure out how that will improve your health. And then we have other group like survival, longitudinal multivariate analysis, which we call SLAM, and things like that. And then there are also some groups that are run by students. For example, we have a general and computing club run by students, and then students basically schedule meetings and meet routinely discussing like some new papers or some like computing techniques, and then it's often served with pizza. Right? So to encourage people to attend. And then we have a biostat student organization, which again is a student-led organization that helps our students in many different ways. Like they have a mentorship program that pairs the incoming student with a more senior students so that you can get some informal advice from them. And then when you come into the department and things like that. So okay, so we are closely connected to several like centers and initiatives. Biostat Consulting Center, I've already mentioned that. And then in the school, we also have a Bloomberg American Health Initiative that tries to address some pressing like public health challenges nationwide, like violence or drug overdose, things like that. And then obviously Biostat plays a big role in those initiatives. And in the university is creating a data science and AI institute. And then in the near future, next few years, universities plans substantially grow in the AI area, and then it will involve a lot of new faculty hires. And we also have faculty playing an important role in that institute. So we are basically closely connected to all these different initiatives and institutes. And there are many more connections, like Center for Computational Biology, like data intensive, like I can't remember the full name, and there's like ideas, like Institute of Data Intensive Science and Engineering, things like that. So there are plenty of opportunities around the university, and then we have close connections to many of them. And then next is the general information about our graduate program. Right? So if we are interested in PhD program, our PhD program provides 5 years of full support. This includes a minimum guaranteed stipend for the next academic year. That will be like 50,000 for PhD students. And then for the year after, you would expect a 4% increase. Right? And then the package also includes tuitions, and your tuition is fully covered by the department. as well as medical benefits. Right? So including, for example, health insurance premiums for students' children and the spouse of international students, okay, depending on the visa type. And then the minimum stipend tuition coverage is guaranteed for at least 4 years. This is just in terms of amount, but our department promises 5 years of support. Okay. And then for the master students, we don't provide full stipends and tuition in your offer letter, but practically speaking, we do have a lot of other support. For example, you do have some tuition benefit, which means like as long as you keep your good academic standing, you're going to have like in total 75% reduction in terms of tuition split over the 2 years, maybe like 50% in 1 year, 25% in another year. And also a lot of master students work with professors as research assistantship, as research assistant. And then through that way, you also get some payment and stipend from the grants. So that's what will happen in practice. Okay. And in terms of the admissions requirement, and for both our PhD and master's programs, we do require you to have calculus and linear algebra training before you join in the program, because as you know, probability and statistics, their foundations are like very like math heavy. We do like need you to have some solid mathematical foundation in order to like sort of do well in our core curriculum. And for PhD applicants, and although calculus and linear algebra are our basic requirement, often you find like the competitive candidates, they also have some other things in their package. For example, some people know more about computer science, right? So they are like they have very like professional like programming skills, whereas some other students they are more like mathematically trained. So if they want to do some theory related research, often we recommend them to take courses like real analysis before they join our program, so that they have a solid mathematical foundation to handle those theory proofs. Right? And as I mentioned before, we also have an MHS program that's slightly different, because for this program, usually currently what we have are like PhD students from other department, and then they are joining our department for a concurrent biostat training. And then so the requirement for this program is slightly different, but still we do require calculus and linear algebra. And for all applicants, we do not require standardized test scores like GREs, and we don't evaluate your application based on those scores. Instead, we evaluate your applications holistically based on or other materials like your transcript, like your personal statement, like your CV, right? So, and also recommendation letters. And we are trying to like learn about you from all this information, like integrate this information. Any question? Okay. So another thing to keep in mind is our application deadline is December 1st, okay? So related to that deadline, especially for the international applicants, make sure to certify your transcript, right? So, so all our international applicants are required to submit like a transcript evaluated by WES or ECE. Okay, so if you have unevaluated international transcript, the admissions office downstairs will not forward your application to the department. So that means we will not be able to review your application. Okay, so in order for us to review your application, the admissions office, the school's admission office needs to have the evaluated transcripts. And that evaluation process will take time. Right? So usually it can take 2 or 3 months of time. So if you want to submit the application, you need to start to work on that now if you haven't. Right? So otherwise it will be too late to meet that December 1st deadline. Okay, so that's one thing to keep in mind. So deadline December 1st, but well before the deadline, you need to start to work on evaluating your transcripts. Okay, so 10 big reasons to get a degree from Johns Hopkins Biostat from a department. First, the number 10 reason is great science, as I mentioned before. You can work on many different topics, ranging from machine learning, artificial intelligence, big data, to solving specific diseases like cancer, immunotherapy, or Alzheimer and aging, things like that. And we have our faculty and students work together to address critical problems. And then these are a sample of the recent research output from the department. You can see that there are papers published everywhere about all kinds of topics like genetics. Nature Genetics are a very high profile place to publish findings in statistical genetics, where our faculty develop polygenic prediction to kind of study the disease in the population. We also have people who develop, for example, things related to Alzheimer's disease, and then using some statistical method here called quantile function, things like that. And then if you come to the department, you're going to learn more about them. And during the COVID, we have a lot of people working on COVID and publishing. We have published a number of COVID papers ranging from how to predict disease progression to how to better run the trials to evaluate different drugs. Okay, so and anyway, this is just a small sample of what's going on in the department in terms of the research. And then if you are in a hallway, you are going to see we have a map here, and then the pins indicate we have a departmental member coming from that area of the world. So you can see a lot of pins. So this is number 8 reason why you want to be in a department. We are very diverse community, and we are proud of these facts that because this actually will help us learn all the perspectives across the world about both the society and the science. And then this actually will often inspire new ideas, and then will help us work on things that actually will benefit everyone in the world. And then obviously we have great faculty members, and then so this slide shows the faculty awards we received in 2023. And in each year, we have many faculty members receiving all kinds of awards. And then this is just some examples of the awards. And for example, Abi, a relatively mid-career, junior mid-career faculty member, received this early investigator award, very prestigious award. And then, for example, John is our a teaching superstar, and always getting this Golden Apple Award, which is the top award that recognize the outstanding teaching in the school. And then we have also Andrew receiving Golden Apple Award, and then many other awards you can see here. And so our department is a close-knit community. We have a lot of fun activities. We have parties together. We have lunch together, meal together. And in this photo, you can see we have a whole departmental meeting where people are eating together while discussing important stuff. Right? So, and then we also have a tea time every Wednesday afternoon. And the school has happy hour Friday afternoon. The department each year has a chili party where we meet, we get together in our department chairs home and cook chilies and compete and to see who has the best chili and things like that. And then when we eat together, we actually also learn from each other in a very informal way, but important way. And Baltimore is actually a very culturally rich city. And there are many fun things like Baltimore Marathon and many other things. You can have this weird event where people just build things and then float on the water and compete. And if you have not tried a blue crab in before, when you come to Baltimore, make sure that you have a try of the blue crab, which is like the signature dish of Baltimore. And then we also have a lot of museums, and both in the Baltimore city and also in close by cities, because we are not very far from DC. Washington, DC is only 40 minutes drive, and then there are a lot of museums there. We are not very far from Philadelphia. It's like 1 hour, 1.5 hour, like Amtrak train. Indeed, we just had our departmental retreat in Philadelphia, and then a whole department went there and then enjoyed 2 days connecting with each other. So this just says like Baltimore actually is a very nice city, and then you get access to many different things. And we have great resource. And as I said, we have a high performance computing cluster that supports most of our computing needs. And then if you feel that is not enough, the university also has another high performance computing cluster called Rockfish. And then in addition, there are also many other clusters. So we have a lot of computing resource, which is good news for people who are data intensive, right? So if you want to do research with huge amount of data, you do have the computing support. And all our students, PhD students, have allocated office space. Master students also have shared offices. And then we have obviously great staff, and then supporting like our students as well as faculty. And we have a highly supportive environment. And then these are 3 testimonials from our 3 students. And then just as one example, it's one example. And here, department's commitments to students' learning and supportive educational environment have been instrumental in my academic journey. Okay, you can read the remaining. But we are proud that our students think this department is supportive of their development, and then they feel happy. So this also makes our faculty members happy, because that's the kind of the nature and the signature of the department. And we have a collegial creative fun community, and then you can see there's a lot of things going on, including besides academics, we have a lot of sports activities, and then we have ping pong tournament, and then our people attend the school's Olympic competition, right? So, and then we actually was the champion, right? And so, and also you can see there are like many like parties, like where people get together, and also like this is the year-end party, so to celebrate New Year, and each year we have some New Year celebration party. And number one reason, the most important reason, is when you come here, besides you besides all this supportive environment and happy life, you also are doing important work in terms of research and other things to actually save millions at a time. So what is public health? Public health is like you are developing, say, new sort of medical solutions or like policies to intervene, so that you are going to improve the whole society in terms of health and in terms of other things. And that will influence many, many people, not just one. It's unlike a medical doctor, right? So medical doctor is a great job, but each time you only treat one patient. In public health, a policy can influence millions of people at the same time. So we are proud that our work will save millions at a time, instead of just saving 1% at a time. So that would be the top one reason for joining a department. Anyway, to summarize our departments, and in our department, you are going to work on very interesting, fascinating problems. And then we are a happy department, and our students have great jobs, and you get training in terms of foundations of statistics and many other things. And you work closely with the mentors, advisors to learn new things and create new things. And then we have people, we have a community of scholars working on many different things. So you can find something that you're interested in. So there's very low chance that you won't find anything if you're interested in statistics. And then it's a great place for you to start your career. And we hope that it will create a valuable experience for your whole life. Okay. So with that, I want to thank you for joining the open house.